Hey everyone, I just wanted to talk to you real quick about something we call multi-dot config in Talos, because it's not really explained a lot of places, but it's starting to be used all over the place. And I just wanted to show you what it is, what problem it solves, and kind of how to use it. So let's start with just what is multi-dot config. And this is just the notion that we take a full machine config, which traditionally is one giant YAML file, which configures the entire operating system. Everything about the OS goes in this one YAML file, and you send it to the API, and the machine installs, creates a Kubernetes cluster. Super easy, right? The problem gets to be, there's some things that need to be configured maybe before you want to install Kubernetes. Things like certificates or network config or file system, something like that. There's a lot of things that might need to be broken up in the config. And traditionally, again, this is just one giant config file, but we started breaking this up a little while ago and didn't really tell anyone. So I just wanted to explain it just to let people know this is happening. And in Talos 1.12, it happens a lot more because a lot of our network config is now part of this multi-dot configuration. For now, almost all of the historical configuration in the machine config is still valid. This is still backwards compatible. It all still works that way, but there are some pieces that aren't configurable in the machine config, and I want to show you how that works too. And the main reason we did this was for things like joining Omni. If you want to join a Talos node to an Omni instance, you need to send it some configuration that it knows how to join the Link config, which is a remote WireGuard configuration, and it has to happen kind of early in the process. So when you are booting a Talos node, you could embed this in the kernel arguments. And kernel arguments are fine for some things, but they also have limits. You can't put anything in kernel arguments. You can only put so much data inside of a kernel arg, and they're kind of hard to change. It's not like an arbitrary thing that gets us away from API managed systems. So by breaking up the join configuration as a multi-dot config, it was one of the first ways that we could say, actually, we don't need to mess with kernel args and we don't need to reboot a box to be able to send this configuration to the machine. And like I said, there's a bunch of stuff that has kind of evolved into this. Things like network config in 1.12 is a big thing that is a change. But all the config right now is still, like I said, backwards compatible. You don't have to rush into this, but I wanted to still explain it and show how it's used. So let's real quickly just spin up a machine and show you how to configure this with multi-doc. And I'm going to use Booter here to boot the 1.12 release candidates. I think it's out fully next week while I'm recording this. So you don't have to set that, but if you haven't checked out Booter, go look at it. I have a video on it. It's super cool. It just gives me a nice little Pixie endpoint for machines on my network. So I have a machine right here. I just turned it on, and we can go over to my KVM and we'll see it boot, and it automatically is set to Pixie boot, especially since the disk is wiped. So there's nothing installed on this machine. I'm just starting from a blank slate to say, okay, whenever you come on the network, Pixie boot, and you can already see it's Pixie booting here in the KVM, and Booter here is grabbing that and then going to send the files over to it to Pixie boot. And this isn't magic. You could set this up with any Pixie server you have. Booter is just like a Talos unique way of doing it that we're just like, actually, we have very specific ways that we can make this fast for you. We already host something called the image factory, which you can see is pulling down from Pixie factory Talos dev, which you get these endpoints if you just go to the image factory. Booter is just kind of gluing those things together and making this a tiny TFTP server and sending the Pixie config to the machine that's on the network that requests a Pixie boot. While that's booting up, I'm going to go ahead and show you the documentation so you can understand how this is working. And if you look on the docs on the left bar here, under reference, we have an overview of just what machine config is. And we call it machine config, and that's the one giant machine config that traditionally does everything. And when you're running something like Talos control gen config, this is what it typically spits out. One big machine config. If I go into these folders here, we can see I have block, I have CRI for runtime, network. All of these are multi-dot configs. Everything in here is a smaller piece of config that can be sent to the API server without doing a full install. So one I like to use is often hostname because it's 3 lines. It's 3 lines of YAML. That's all we need in it, and we can use this to actually configure a machine. So we see the machine here is up, it's in maintenance mode, and it's just waiting for API, call the API, send a configuration, and if you've watched anything in the past, usually you send a machine config. I don't need Booter anymore. The machine's fully booted in memory. It's ready to go. Booter's only listening for network boot request. So now traditionally we would do something like Talos control gen config, give the cluster a name. I usually call this one Z because that box host name on my network is typically Z, and then the endpoint. And this is 10.1.1.26.6.4.4.3. Fun stuff. This generates the 3 files that I'm used to. Now let's look at one of those files. Let's just look at the control plane, and we're gonna go all the way down to the bottom here, and we can see I get a line break here in YAML. This is a different document. This is how YAML appends multiple documents together. And in this case, it is sending a hostname config, which is a multi-doc config by default in Talos 1.12. And this is using the default values of what I normally would want to see for this config. It's just saying, give me a stable hostname, and it's gonna append that to this file. It'd be the same thing as sending a patch, right? Multi-doc config can be patches that you send to the API as well, or you can concatenate all of them together into one giant file. We don't actually have to use that, so let's go ahead and look at hostname.yaml. Let's just make a file, and I'm going to copy it right out of here, and then I will name this host Z. So this is all I need to send a multi-doc config to this machine. And now I can apply it. This is typically how you would apply the full machine config. But again, I'm only sending a multi-doc component, just the piece that I want to configure. I need it to be insecure because it's still in maintenance mode. And then I also need the node. This is 10.10.1.26. Sent it. Configuration was sent. You would see it here in the logs, and you'll notice up here, if it's really small, but you'll notice at the top there is still no host name. I don't actually have a host name set because some of this config requires an install to take place. So things like user volumes are multi-doc config, but they don't actually apply to the system until the system's told to do an install, because it's not going to format the drive just because you sent a multi-doc config to it. And this is where some people get into trouble. I 100% got into trouble doing this because I was sending trusted CA certs to an endpoint in multi-doc and maintenance mode, but I was not sending that same multi-doc config with the machine config during installation. So the multi-doc config was being wiped out by the machine config with its own default values. So if I go into this here in this full machine config control plane, and I delete out the host name at the end, what I would want to do to then apply this so that both the patch that I have and the full machine config apply is I would do apply control panel or control plane YAML. I'm still in insecure mode. I still have my node, and I'd also want a patch for hostname. That's how I would send both of these concatenated together to do a full install on the machine. And I think I actually have something wrong in my control plane because I didn't have my install disk. So let's go ahead and fix that real fast with disk.yaml. And now I'm going to make a normal patch. This is something that isn't multi-doc, but you should be managing patches with separate files. You don't want to commit the whole machine config. You want it to be a separate file. So if I go in here and I look at install, it's machine install disk. That's what I need. So I'm just going to do machine install disk dev nvme. It's that. So now I could do house control apply control plane I 10.1.1.26 patch hostname. Actually, I think I still need that for this version, and also I can do another patch of what do I call it, disk. And now when I apply that patch, send that config, I should get the full, everything gets rendered together into one giant machine config. That all gets sent to the API. It does its install. It's going to reboot after the install, and I'll have a machine waiting for me. We see it booting up now, and now you'll actually see in the very tiny top corner here, I do have Z as my host name. If I actually want to read back all of the machine config with patches, I would do control. Actually, let me export my Talos config, which is here. So get MC, and then I would want to do my node 26, and it's also my endpoint. I can see I have a machine config, and so I want YAML. And now I can see, here's my multi-doc config that came back out of the API. I can still see it concatenated at the bottom, even though I deleted it from the config. I sent it as a patch. If you are doing things like trusted certs, all that sort of stuff, they would be in here. And then I should also see my NVMe disk. This is different, right? Because this was a patch to the config, not a multi-doc. That's how they get merged together. So just to clear it up a little bit, you do want to manage your patches to machines as separate files. You want to manage your multi-doc config as separate files as well. They show up differently in the API. But let's wipe this box. I just wiped the machine, and I'm going to reboot it into Talos 1.11 to show you the machine config. Now, in this case, our machine config is available in Omni. We can get it through the CLI or the UI, and it's over here on the home page on this right side. Download machine join config. And this is a multi-doc config that you can send to any Talos node to connect into this Omni. You'll see here I have no machines in the Omni instance. And as soon as my machine boots, it's going to, again, be in maintenance mode, waiting for me to send a config. And even at this point, Booter's out of the cycle of needing to send requests. It already sent the iPXE file, and now the machine's just downloading. I don't need to do anything on it. But if I look at my machine config here, this is my multi-doc config. And it actually has 3 documents in it, right? I have my initial, where's my set error link, and my join token to authenticate this machine to that endpoint, and then where do I send events, and where do I send my kernel logs. All of those things are additional multi-docs that just happen by default, right? You don't really have to worry about it. It's going to apply no matter what. Okay, so once my machine is booted up into maintenance mode, I can see here that I have a set error link of NA, meaning it's not available. It received no configuration to join any set error link endpoints, but I can send that machine config to the endpoints. Immediately, I'll get a set error link config here showing up in the dashboard itself. And as soon as that goes green, I can go back over to my Omni instance and I see the machine has joined. Now what? Now the machine can be, it's not installed, it's still booted in memory, but I have a join config. I have a machine configured and joined into Omni, and now I can create it as, I can make it a cluster, right? So now it's available to me to make it a control plane node, automatically get that disk selection, and create a cluster here. All of that flow is already like typical way of doing it with Omni. So that's it. I really just wanted to show you what multi-doc is, why it exists, what problem it's solving, and where some of the new stuff is headed. So look at that network config in Talos 1.12. You'll see a whole bunch of it is multi-doc now, and talk to you again soon.